Hey, in this video, I'm going to be making organic chemistry simple for you. You just stay tuned and listen as I take you through the reactions of carbonyl compounds. Now, organic chemistry, what we are familiar with is the compound that involve only carbon and hydrogen. That's what we call the hydrocarbons. But in advanced chemistry, we have a compound that contains about 3 elements. And the third element that join the carbon and hydrogen is oxygen. Our normal alkane or alkyne is of this shape. But in organic chemistry, when we talk of carbonyl compounds, that compound possesses a doubly bonded oxygen. There is an oxygen present in the compound, but the orientation at which the oxygen bond is double, not one. Because oxygen has the full power to bond double bond. You can arrange the bond of oxygen even like this, at least satisfying the oxygen by 2 bonds. But in carbonyl compound, what we are saying is that the oxygen is not bonded with double bond or with single bond. It is bonded with double bond. So whenever you see a doubly bonded oxygen on the carbon chain in the compound, that compound is such an example of what we call a carbonyl compound, and they are much. The first compound that have this functional group is the aldehydes and ketones. Aldehydes and ketones. Aldehydes, which can also be called alkyl, and ketones, which can also be called alkanones. But the second member is what we call carboxylic group. Their own functional group is COOH. We notice that this one now contains 2 oxygen, but one oxygen is not bonding double. One is bonding double. So this thing is not carbonyl because of this oxygen. These compounds are carbonyl because of this doubly bonded oxygen. So when they ask you, what is the functional group of a carbonyl compound? It's the doubly bonded oxygen. So you always locate it, and once you find it, that compound is a carbonyl. And then the name of this one, because it includes OH with the double bonded oxygen, call it carboxylic acid. That's the old name, and the new name is alkanoic acid. Alkanoic acid. But in this video, we have a lot of them. We have acid anhydride, we have amide, we have acyl chloride, we have a lot of them that have at least a doubly bonded oxygen. We group all of them into what we call carbonyl compounds. But in this video, I'm going to be taking you through the reactions of carbonyl compound 1, which is the aldehydes and ketones. Aldehyde and ketones. So let's start. Aldehydes and ketones. Aldehydes and ketones. Whenever you hear reactions, one thing that should come to your mind is the preparation. How do you prepare those substances? We want to react carbonyl compound, aldehyde or ketones, adding different things to them. What do we get? So, but before you do that, you must produce them. How can you produce this alkana or alkanol before they react? Before using them in reactions, how can you produce them? That's very, very important, and it will be a good skill. It will be a good skill for you as a chemistry student. Now, I will quickly show you about 3 ways of how to prepare alkana or alkanol. But in my subsequent videos and space for it, I'm going to explain the reactions. But now, because I'm only going to go to the reaction, what can those alkana and alkanol do? Okay, if I add water, if I add alcohol, what will be the product? But I will just show you the name of the reactions, the preparation reactions, and the product you are going to get. And definitely you are going to get alkana or alkanol. But I'm just going to show you the name of the product and the reaction condition. Number 1 way of producing aldehydes or ketones is oxidation. Another way is ozonolysis. Another way is hydration. Now, these three things are different action: oxidation, ozonolysis, hydration. So, who is the recipient of this action? Like if you do those things to those ones, you are going to get your aldehydes or ketones. Oxidation of alcohol, ozonolysis of alkene, hydration of alkyne. These are the three major ways that you can produce alkanal or alkanol. If you oxidize alcohol, you will get alkanal or alkanol. If you ozonolize alkene, you get alkanal or alkanol. If you hydrate alkyne, you get alkanal or alkanol. So now, these things are the three ways of producing aldehydes and ketones. So the condition of reaction, because for every reaction there's a condition, and the condition determines the product. So your ability to be able to know a particular condition for a particular reaction. No reaction have the same condition. It's very, very rare. So you identifying a particular condition for a particular reaction will be of a great skill. So if I'm oxidizing alcohol, my condition of reaction is an oxidizing agent like KMnO4, K2Cr2O7. And what they are doing is that they will supply you with oxygen. Of course, that's the ability of an oxidizing agent. Then the condition of reaction or ozonolysis is ozone, depends on zinc and water, what we sometimes refers to as zinc dust. Then finally, for alkyne, hydration of alkyne, the condition of reaction is water. Since you are adding water is a condition of reaction. So if you perform all this action on each of these recipients, you are going to get alkanal or alkanol. Oxidized alcohol, you get alkanal or alkanol. But know that oxidation of primary alcohol gives alkanal. Oxidation of secondary alcohol gives alkanol. Ozonolysis of alkene, depending on the type of alkene you have, depending on either you get alkanal or alkanol. If you have a straight alkene, a straight chain alkene that does not have a branch like butane, propane, you are going to have alkanal. Two products, but it will be alkanal. Because in ozonolysis, we are having more than one product, like 2 or 3. So, but if it's a strain alkene that you are ozonolizing, we get alkanal. But if there is a branch on the name, and particularly the branch is on one of our carbon hosting the double bond, at least you will get one alkanal and one alkanol. Example, you can say 2-methyl-butene. So the methyl is attaching to one of our carbon hosting the double bond. So when you split it, when you ozonolize it, we are going to get one alkanal and one alkanol. So those things are just a prerequisite. Then if you hydrate alkyne, hydration of alkyne will lead to an intermediate species called enol. So enol is not a stable compound, so it will tautomerize, what we call rearrangement. And when there is a rearrangement, it's going to now give us our alkanal or alkanol. So I think that's very good start. So we'll stay tuned to my video after I release. I will talk specifically on the reaction process of all those 3 ways of producing alkanal and alkanol altogether. Now let's go to the reactions of this compound. Now I've introduced you to how to prepare them, which I've not explained in details in the subsequent videos. But now let's take ourselves through the reactions. Now, carbonyl compound, either alkanal or alkanol, can actually undergo this reaction, which I code as cargo WCDPA. Cargo WCDPA. And this is the meaning of all those letters. C for clemency, A for addition of water or alcohol, R for reduction, either Wolff-Kishner or with reducing agents. There's one of such reaction that we call Wolff-Kishner. The name of the scientist is Wolff-Kishner. As time goes on, I'm going to be showing you what we do in that reaction to alkanal or alkanol. Then the G, cargo, the G stands for Grignard reduction. You can reduce the oxygen on alkanol or alkanol by what we call Grignard reagent. There's a special reagent like that you can use to reduce alkanol or alkanol. Then the O stands for oxidation, the W, Wittig reaction, the C stands for reaction with cyanide, the D stands for what we call desulfurization reaction, the P stands for the reaction with peroxyl acid, while the A stands for the reaction with primary amine. So we are going to be taking ourselves through all these reactions. Alkana or alkanol, which is one of our representative members of carbonyl compound. Those compounds that possess a doubly bonded oxygen. Please take note of that word. Any compounds, organic compounds that have at least one doubly bonded oxygen is a carbonyl compound. And we are now going to take ourselves through the reactions of the first of them, which is aldehydes or alkana, and ketones, which is also known as alkanol. So now let's take ourselves through this. But before I am going to take each reaction one after the other. But before I do that, I'm going to give you a table, because in every chemical reaction, we have what we call components of a chemical reaction. Particularly when it comes to organic chemistry, we don't play with our component of reaction. And the component of reaction is divided into three. We have the precursor, the condition, and the product. The precursor, the condition, and the product. Now, I'm not going to give you the name of the reaction name, the condition of that reaction, and the product. Now, take for instance, you are cooking rice. Now, take for instance, you are cooking rice. Now, there are some conditions that must be met. If those conditions are not met, you are not going to get your expected product. The gas, the ingredient, the matches that you are going to on the gas. Without those conditions being met, you are sure that you are not going to get your eatable rice. That's what we are saying. Your ability to be able to identify each reaction with its own condition is a good start for you. Now, calm down. As I'm going to be giving you this table, study it. Know a particular condition for a particular reaction, so that anytime you come across that condition, you can quickly think faster than which reaction is this condition pointing to. And know that the condition for cooking beans or cooking swallow will be different from the condition for cooking rice. So I can actually depict the type of reactions by the condition. So please take note of it. Learn each reaction with their condition. It's important for you. It's important for your product. It's important in organic chemistry. Now, the first reaction, as you know, is cleansing. From my abbreviation, CarbonyL. Cleansing reaction. The condition of the reaction is zinc or mercury in the presence of an acid, HCl, hydrochloric acid, and the product we give you is always an alkane. Then for my cargo, the A means addition. But if you add water, addition is in two ways: addition of water, addition of alcohol. If it is addition of water, the condition of reaction is the water you are adding. That's the condition. Then the product will be a diol. A diol is one type of alcohol that contains 2 OH. You can also call it a dihydric alcohol. So you will be seeing something like ether 1,1 diol. You will see 2 OH group on the same carbon. That's what we call diol. And we call it gem diol. Because whenever you have 2 functional groups on the same carbon, it's a gem isomer. Gem, GEM. So it's a gem diol. Now, addition of alcohol. If you add alcohol to alkana or alkanol, the condition of reaction is the alcohol you are adding. It can be methanol, it can be ethanol, it can be propanol, any alcohol you are adding. The answer, the product, is always what we know as aceta. As time goes on, I'm going to take you through what is the reaction. Then you now see how we get acetal product. Then the next one is the reduction reaction. reduction. Now, reduction reaction can be the one of Wolff-Kishner. There's a lot of actually under this carbonyl compound, we are reducing oxygen. So there's a lot of reduction reaction. But one of its kind is what we know as the Wolff-Kishner reaction. Wolff-Kishner. And the condition of reaction is hydroxine, and the product is always alk. Always alk.